In this tutorial, we will introduce the Spring framework and how we can use it with our Jakarta Java Enterprise Edition version 8 application. The Spring framework is an open source framework used in Java Enterprise application, and it's known for its flexibility, its modularity, and scalability. This is an overview about the history and evolution. It started out in 2003, mainly to address complexity concerns with a technology known as Enterprise Java Beans. Since around 2006, it kind of evolved with all the Java Enterprise editions, and currently it coexists with Jakarta Enterprise Edition, and it has been expanded beyond the Java Enterprise Edition. The key concepts: inversion of control and dependency injection, aspect-oriented programming, data access, and object relational mapping, and then transaction management. Here are some more advanced concepts. There is application messaging, which are known as MQs, and then there is the model view controller framework for web application. We look at the current state. Spring is still extremely popular, and you will probably run into it. It's been expanded beyond the capabilities of the Jakarta Enterprise Edition framework, and we see that it exists with the Enterprise Edition version 8 framework. There is also some extra initiatives such as the micro profile, and there is an open source collaboration within the Java community. Now we are going over to our course documentation. Here is the deeper dive. Spring Framework is a cornerstone of the open source frameworks. It's dedicated to the construction of enterprise level Java application. It has comprehensive infrastructure support and has simplified configuration and integration within application. Flexibility and modularity, amazing ability to foster the development of scalable and maintainable application. Let's look at the history again. In 2003, an Australian named Rod Johnson came up with the idea as an alternative, of course, to enterprise Java Beans. This period marked the emergence of Spring to simplify the landscape of Java enterprise development, countering at that stage the heavyweight components of the Java Enterprise Edition. And then from 2004, Spring became hugely popular because it was easier to create a database enterprise application than it was with the enterprise Java Beans. In 2006, Spring 2 came out, and that was aligned with the Java Enterprise Edition 5. At that time, it maintained the straightforward and flexible programming module. In 2009, Spring 3 came out, this time matching with Java Enterprise Edition 6. Now we had annotations and more simplified configurations in both Spring and Java Enterprise Edition 6. In 2013, with Java Enterprise Edition 7, Spring 4 came out, and it evolved in tandem by incorporating new features and enhancements. Now currently, Spring is, I believe, up to 5 or 6, and it is keeping pace with the newer, faster pace now that Oracle has taken over, and also the open source Java community. Now we look at the key concept, which is inversion of control, where the control flow shifts from being determined by program logic to being inverted, where the framework calls user-defined methods. It uses a bean factory and an application context, which efficiently manage the creation and handling of application contexts. Then there is dependency injection, which is a specific type of inversion of control. It involves providing objects with their dependencies rather than having them create or search for dependent objects independently, which minimizes couplings between your components and also enhances your modularity and makes it easier for unit and integration testing. Then there is aspect-oriented programming. So here the words are to make you feel smart. A paradigm dedicated to increasing modularity by segregating cross-cutting concerns. These concerns affecting multiple modules such as logging, security, and transaction management. Now what this means is essentially you can provide a start and an endpoint in any of your components where you can call these external logic. So it's kind of annoying that these guys try and sound so smart to me. Then there is data access, Spring JDBC. This is an enhancement of the Java JDBC with the JDBC template class, which essentially provides you out of the box with everything you need to hand code when you use JDBC. Then there is object relational mapping, which is a way of mapping your components to the database. And there's a bunch of frameworks like Hibernate, MyBetas. Currently in Java Enterprise Edition, it comes with. Then there is transaction management. Once again, you use declarative approach using annotations or XML configurations, the same as in aspect-oriented programming. You can also use the transaction template or by directly working with the platform transaction manager interface. Then there is application messaging, which is a messaging abstraction. Helps with the development of event-driven and message-based application, leveraging the message and message channel interface, which allows asynchronous communication between components. And there's message-driven POJOs using message mapping, allowing for processing of messages in a decoupled manner. Then there is the integration with message brokers, such as RabbitMQ, Apache Kafka, and the Java message server. Then there is the Spring Model View controller for web applications. The controller is entrusted with handling user requests, processing them, and determining appropriate response. The model represents the data and business logic. The views are tasked with presenting data to the user. You can use Java server pages or the Timeleaf template or any other template engines. Then there is the dispatcher servlet and handler map. This is your central component managing all incoming requests and dispatching them to appropriate controllers. So think of that as central control. Now we look at the current state in relation to the Java Enterprise Edition 8 framework. Here we have the updates to the servlet, API, and CDI. JPA is Java Persistent Architecture. We see that they both coexist within Java, although they are not technically part of the Enterprise Edition. Then we see the Micro Profile Initiative. This is geared towards microservices. And we see that there is open collaborations between the Spring and the Jakarta Enterprise Edition proponents or developers. Spring remains very relevant, and in enterprise development, you will run into it. Let's explore the advantages of transitioning our charity registration application to the Spring framework. First, we see that we have a bunch of servlets all over the place. And in our servlets, we have the do get and do post methods. And within most of them, we have logic done through the action and command pattern, as we see here in the charity registration servlet. And the same goes for the chat servlet, which means our business logic are distributed all over the place in our servlets. So what we need is a more organized and modular approach where we emphasize the separation of the model, the view, and the controller. And this is where transitioning to a MVC framework, which in our case will be Spring MVC, will come in handy. Of course, Spring MVC are not the only MVC Java framework out there. We already covered Java server faces in this course, and another legacy MVC is the Struts framework. So what we'll do here is we will use Spring controller servlets in the back end, and we will map them to our presentation elements. This will allow us to simplify unit testing our back-end controller methods, and it will give us precise control over parameters, headers, footers, and dynamic content on the presentation side. Moreover, the transition allows us to logically group our code and streamline application flow. Business logic currently embedded in our servlets and presentation elements can be extracted and placed into dedicated pojos. Now, if we go over to our presentation layer with our JSP forms and our tag layouts, one of the advantages that Spring MVC provides us is the ability to provide interchangeable presentation elements tailored for different platforms. This means that our application can seamlessly adapt to micro devices, phones, web browsers, and even legacy green screen applications. This versatility ensures a consistent and optimal user experience across a diverse range of devices and interfaces. Coming up, we will move everything over to Spring MVC and the Spring Data Persistent Framework. And that concludes this tutorial. I will see you in the next one.